friends, welcome to Ignite Max. At this video we are going to do the chapter of the trigonometric functions. Okay, it's nothing but the third chapter of the Max part 1 12th standard MH board. Okay, so this third chapter is completely based on the trigonometric equation and its solution. Okay, the polar coordinate, Cartesian coordinate, the sine rule, cosine rule, projection rule, inverse trigonometric functions, principal values of the inverse trigonometric function. The club of the topics are involved in this chapter. So let's get started with the exercise 3.1. It's based on the trigonometric equations and its solution. It's nothing but principal solution, and the general solution is we need to do it. For finding the principal solution, we need to clear with the concept of the allied angles. For finding the general solution, we need to remember certain formulas. Okay, that's just displayed on the front of the screen. Just note it down and let's get started with the exercise 3.1. Start with the exercise 3.1. We need, at the first main question, we need to find the principal solution of the following equation. For finding the principal solution, the angle, the theta, lies between 0 to 2 pi. Yes, and the next tool is by the allied angles we can find the principal solution, and on the principal solution the solution may be finite. Okay, at the general solution it's definitely infinite. This is what the difference between the principal and general. So we have the allied angles formula on the one side, yes, and the trigonometry table on the other side. Let's get started with the solution part. So I took the second sub question over here. It's nothing but sec theta is equal to 2 by root 3. We need to find the principal solution of the theta, the angle. So we need to identify the sec theta value from the trigonometry tables. Just showing on the side, it's nothing but sec pi by 6 is equal to 2 by root 3. Yes, it's nothing but one of my principal solution, theta is equal to pi by 6. Yes, the other solution by the trigonometric functions of the allied angles, that is nothing but sec 2 pi minus theta is equal to sec theta. If we are doing with the sec pi minus theta, pi by 2 minus theta, pi plus theta, any value or the complementary, otherwise the supplementary, I'm getting the negative term. So if sec 2 pi minus theta, then we used to get the positive angle because the sec is positive. Yes, 2 by root 3 is positive. We need to get it as sec dash minus theta is equal to sec theta. In this form we need to get it. Okay, but if we will do the other angles like pi minus theta, pi by 2 minus theta, pi plus theta, we will be getting the answer as negative, otherwise the trigonometric function has changed. Sec 2 pi minus theta is equal to sec theta. Yes, now the theta, it's nothing but pi by 6. If we can put the value also, is all right. So let's take the solution part over here. Sec pi by 6 is equal to sec 2 pi minus pi by 6. Yes, over here we have arranged theta is equal to pi by 6. Yes, so the same thing I have repeated, only the theta thing I have substituted as pi by 6. So 2 pi minus pi by 6 multiply by 6 at numerator and denominator, will be getting the answer as 11 pi by 6. So sec pi by 6 and sec 11 pi by 6, we will be getting the answer as 2 by root 3. Yes, and are it's lying between 0 to 2 pi? For principal solution, the theta, the angle should lies between 0 to 2 pi. Yes, it's absolutely lying between 0 to pi, pi by 6 and 11 pi by 6. So the principal solution are theta is equal to pi by 6 and theta is equal to 11 pi by 6. So other way of doing also, that is nothing but over here we got the question as sec theta. Yes, okay, we can convert into cos. It is nothing but sec theta is equal to 1 by cos theta. So cos theta will become as root 3 by 2. Okay, in that format also we can do it. We will be getting the answer same. If not, without changing the trigonometric functions also, we will be getting the answer same. So both the way is accepted. Now we'll take one more example in which the sec theta, the trigonometric functions, contains a negative value. So how we need to deal with it? Related to it, we'll just do the solution. Take the third sub question. So the question is cot theta is equal to root 3. As previously we have mentioned, we can change the sec theta is equal to cos theta also, that is nothing but root 3 by 2. In that format also we can do it. So I took the other example in which the cot theta is equal to root 3. So I am going to change this as tan theta. It's nothing but tan theta is equal to 1 by cot theta. In that format also we can find it. So tan theta is equal to 1 by root 3. First we need to check the trigonometric tables, that tan pi by 6 is equal to 1 by root 3. Yes, from the trigonometry tables. And by the trigonometric functions of the allied angles, we need to represent as tan dash plus theta is equal to tan theta. Okay, tan theta we need to get it. So at that moment we got the answer as pi plus theta. So the theta is pi by 6. So just substitute the value over here. Yes, tan pi by 6. The same thing I have written. Yes, tan pi plus pi by 6. And it's nothing but 7 pi by 6. First we need to check, is this lying between 0 to 2 pi for the principal solution? Yes, it's absolutely lying between 0 to 2 pi. Yes, so the principal solution are theta is equal to pi by 6 and theta is equal to 7 pi by 6. Because while presenting in the board, we need to represent all on these steps. Yes. The second main question, we need to find the principal solution. Okay, what's the difference between the first main and second main question? So at the first main question, each and every trigonometric function contain the positive term, like sec theta is equal to 2 by root 3, cos theta is equal to 1 by 2, and we have found the principal solution. Now there is a quite twist on it and the second main question, in which it contains the negative trigonometric function, like sine theta is equal to minus 1 by 2. So how we need to deal with it, like over here. So how we need to present it, let's get started. So the question is sine theta is equal to minus 1 by 2. Okay, know that sine pi by 6 is equal to 1 by 2, but the question is given as sine theta is equal to minus 1 by 2. Okay, so at that moment we need to do with the trigonometric functions of the allied angles, a complete thing. Okay, so we need to represent the form of allied angle, that is nothing but sine dash plus theta. Yes, sine dash plus theta is equal to minus sine theta. And one more. Okay, for principal solution we need to find two solutions. So it's nothing but sine dash minus theta or plus or minus theta. We need to get the answer as minus sine theta. Okay, sine functions we need to use it and we need to get it the answer as minus sine theta. Okay, both the function at that moment pi plus theta and 2 pi minus theta, we will be getting the answer as minus sine theta, that is nothing but minus 1 by 2. So I'll just represent the theta as pi by 6. Yes, so let's do the calculation. Sine pi plus pi by 6 is equal to minus sine pi by 6, in which sine pi by 6 is 1 by 2. So minus I have represented on it. Okay, and over here also we will be getting the answer as minus 1 by 2. The thing is, we need to use the trigonometric functions and we will be getting the answer as minus sine theta. Sine, we need to use the allied angles, so that we will be getting the answer as minus sine theta. And the first main question, we have used it, but we need to get it as positive. Yes, but over here the question itself is negative, so the solution also we need to get the answer negative. So by the trigonometric function of allied angles, we got it over here. Now we need to do the calculation of pi plus pi by 6 for finding the solution. So sine pi plus pi by 6 is nothing but 7 pi by 6 and 2 pi minus pi by 6 is nothing but 11 pi by 6. Okay, it's nothing but the solution is minus 1 by 2. Yes, and is this lying between 0 to 2 pi? Yes, it's absolutely lying between 0 to 2 pi. So it's nothing but the principal solution. Yes, theta is equal to 7 pi by 6 and theta is equal to 11 pi by 6 are nothing but the principal solution. For doing the third sub question, okay, the question is given as root 3 cosec theta plus 2 is equal to 0. So we need to find the principal solution. Okay, what we need to do, root 3 cosec theta is equal to minus 2. Yes, and cosec theta is equal to minus 2 by root 3, and by the trigonometry tables with the trigonometry function of the allied angles we can find it. Okay, we have came across the principal solution. Now let's move to the general solution. So from the third main question is based on the general. Okay, Here is the quite formulas we need to remember for doing the general solution. Yes, if sine theta is equal to 0, cos theta is equal to 0, what will be the general solution? A complete concept is displayed over here. Please note it down, otherwise take a screenshot of it for finding the general solution. So let's start with the third main question. The sub question is completely correlated with each and everything. If we are completed with the one sub question only, we can do the other sub question. So I took the second sub question. We need to find the general solution. The question is given as cos theta is equal to root 3 by 2. First thing, we need to identify the root 3 by 2 by the trigonometry tables. Yes, so it's nothing but cos theta is equal to root 3 by 2. It's nothing but cos pi by 6. Yes, cos pi by 6 is equal to root 3 by 2 by the trigonometric tables. Now, we need to identify the general solution of it. Okay, first, here is some display of some of the formulas over here, in which we need to identify which of the formulas we need to use it. It is in the form of cos theta is equal to cos pi by 6. It's nothing but cos theta is equal to cos pi by 6. Yes, by the general solution formula. Then the theta is equal to 2n pi plus or minus alpha. So the theta over here is theta they have represented. The alpha they have represented as a pi by 6. Yes. So we need to represent as theta is equal to 2n pi plus or minus pi by 6, in which n belongs to the integers. Okay, the simplest question, we have found the general solution of it. Just we need to use the formula and we will be getting the answer. Fourth sub question. Okay, so I'll just display the question over here. Cot theta is equal to 0. Yeah. For finding the general solution, if it is in the form of cosec, sec, cot, make sure that we are converting in the form of sine, cos, tan. Yes, we know the ratio of it, we know the reciprocal of each and every trigonometric function. So the cot theta, the reciprocal is nothing but 1 by tan theta. So tan theta is equal to 1 by cot theta. Yes, so when we are doing it, cot theta is equal to 1 by tan theta, but we know the cot theta value is equal to 0 according to the question. So 1 by tan, it's nothing but 1 by 0. Yes, 1 by 0, it's nothing but the infinity. 0 by 1 is equal to 0, but 1 by 0, it's nothing but infinity. At that moment, tan doesn't exist. Okay, so it's nothing but tan theta is equal to tan by pi by 2. It's in the form of that, in which tan pi by 2 doesn't exist over here. The value is infinity. According to the trigonometry table, we will check it. The tan pi by 2 is equal to infinity. So we need to find the general solution. Yes, first we need to identify which are the formulas we need to use. It is in the form of tan theta is equal to tan pi by 2. It is in the form of tan theta is equal to tan alpha. Yes, so the theta is equal to n pi plus alpha. Yes, in which n belongs to integers. So theta is equal to n pi plus pi by 2, in which n belongs to the integers. Okay, the question is given in the cot, so I have converted the tan which I have got it doesn't exist. So I have represented the general solution and we got the answer. Forget this calculation that 0 by 1 is equal to 0, but 1 by 0 is equal to infinity. Don't write it the 1, and the solution part also will be changes. So make sure related to the calculation. To the fourth main question, here also we need to find the general solution, but the thing is over here the negative part is involved, like cosec theta is equal to minus root 2, tan theta is equal to minus 1. So how we need to deal with it, that we are going to see it over here. So I took the first sub question. We'll start with the basics thing. So we need to find the general solution, in which the question is given as sec theta is equal to root 2. First step, it's nothing but we need to convert in the form of sine, cos, tan. So it's sec, so this reciprocal of sec is nothing but 1 by cos. So cos theta is equal to root 2. Yes, cos theta is equal to root 2. Now 1 by root 2, it's nothing but cos of pi by 4. Yes, according to the trigonometry table. So it is in the form of cos theta is equal to cos alpha. Yes, so by the general solution, theta is equal to 2n pi plus or minus alpha, in which n belongs to the integers. So theta I have represented in the place of alpha, we need to represent as the pi by 4, and we will be getting the answer. Start with the second sub question. So the question is given in the negative form, that is nothing but minus root 2. Yes, cosec theta is equal to minus root 2. So still we will do it. First step is we need to convert in the form of sine constant. So the cosec theta, the reciprocal of cosec theta is nothing but sine theta. The sine theta is equal to minus 1 by root 2. Yes. First identify 1 by root 2. What will be the value according to the trigonometry tables? So it's nothing but sine of pi by 4 is equal to 1 by root 2. But it's in the minus. So according to the trigonometry function of the allied angles, we will do it. But still sine pi by 4 is equal to 1 by root 2. So sine theta is equal to minus sine pi by 4. Yes, by the trigonometric function of the allied angles, sine pi plus theta, we will be getting the answer as minus sine theta. Yes. So theta have represented in the form of pi by 4. So sine pi plus pi by 4, we will be getting the answer as minus sine pi by 4. That is nothing but minus 1 by root 2. So the general solution is sine 5 pi by 4. Yes. So the general solution, the formula sine theta is equal to sine alpha, theta is equal to n pi plus minus 1 raised to n alpha. N belongs to integral. The n is nothing but 5 pi by 4. Just replace the alpha as 5 pi by 4. That's nothing but the general solution of it. Okay, this is how we can find it. Over here, we have done the conversion of sine pi plus theta is equal to minus sine theta. Okay, we need to use the trigonometry function as sine. Yes, according to the question. And we need to get the answer in minus form. For that purpose, we have done the sine pi plus theta. Yes, now let's move to the fifth main question. Here, the second sub question. So tan 2 theta divided by 3 is equal to root 3. Yes, first we need to identify the trigonometry tables of root 3. It's nothing but tan of pi by 3 is equal to root 3. Yes. So I'll just keep it as like as 2 theta divided by 3. Any angle 4 theta divided by 3, 5 theta divided by 3. Just keep it as like as we'll find the general solution and we'll just substitute over here. It's nothing but tan theta is equal to tan alpha, theta is equal to n pi plus alpha. Yes. So the alpha is nothing but pi by 3 and theta is nothing but 2 theta by 3. Yes. Now over here, take it in the RHS form. 2 by 3, take it in the RHS. It will be form of 3 by 2. Yes, multiply 3 by 2 with each and every time and we'll be getting the answer as. Here, the question is in the form of double angle. Okay, sine 2 theta is equal to 1 by 2. Tan 2 theta divided by 3 is equal to root 3. Okay, we'll just do it and we need to find the general solution. So, sine 2 theta is equal to 1 by 2. Just forget this 2 theta related to it. Okay, double angle formula, just forget it because we need to find the general solution. So 1 by 2, it's nothing but sine pi by 6 is equal to 1 by 2. Now what we need to do, it is in the form of sine theta is equal to sine pi by 6. Yes, so the general solution is nothing but theta is equal to n pi plus minus 1 raised to n alpha. Yes, so theta over here they have represented as a 2 theta. Yes, just write it as like as n pi, keep it as like as minus 1 raised to n, as like as alpha is nothing but my pi by 6. Yes, now theta over here divide each and every term by 2. So you will be getting the answer. Let's move to the sixth main question. Okay, over here also we need to find the general solution. Okay, it's a correlated with the fifth main question only. We'll just do it over here. Okay, so it's in the form of 4 cos square theta is equal to 3. Over here it's in the form of square. Yes, so but we have the formula for that also. The general solution is nothing but cos square theta is equal to cos square alpha. If it's in that form, theta is equal to n pi plus or minus alpha according to the formula. So over here 4 cos square theta is equal to 3. So cos square theta is equal to 3 by 4 if I will take the 4 over here, and it's nothing but root 3 by 2 the square. So cos square theta, it's nothing but cos pi by 6 square. Yes, so it's nothing but cos square pi by 6. Now it is in the form of cos square theta alpha over here. The same thing, it's repeated. So just replace the theta over here and alpha, it's nothing but pi by 6. And we got the answer. Let's move to the third sub question. Cos 4 theta is equal to cos 2 theta. It is the form of cos theta is equal to cos alpha. Yes, cos 4 theta is equal to cos 2 theta. Okay, just compare with the formula and we'll be getting it's nothing but cos 4 theta is equal to cos 2 theta, in which over here according to the formula theta is equal to 4 theta and 2n pi plus or minus alpha. Alpha over here is 2 theta. Okay, just put the value accordingly and we'll find it. Okay, so I'll just put the accordingly find and got the answer as 4 theta is equal to 2 n pi plus or minus 2 theta. Okay, it is in the form of plus or minus. Okay, we'll need to find the general solution. So first we will take the positive sign, secondly we'll take a negative sign. So I took the positive sign, it's over here. So 4 theta is equal to 2 n pi plus 2 theta. Yes, in which we can find the value of theta over here. Yes, 4 theta minus 2 theta, 2 n pi. So the 2 cancel. So the theta is equal to n pi, in which n belongs to integers. Over here we have took the positive sign of it. So let's take the negative sign. The other part is nothing but 2 n pi minus 2 theta. So 4 theta is equal to 2 n pi minus 2 theta. So the answer will be 4 theta plus 2 theta is nothing but 6 theta is equal to 2 n pi. So the theta value is equal to n pi by 3, in which n belongs to integers. So the theta is n pi by 3, otherwise n pi. Okay, in which n belongs to integers. This is for the general solution. To the 7th main question. Okay, I took the second sub question over here. We just complete with the second sub question and move to the first sub question. I'll say a small hint for doing it. Okay, for the first main question. So after just completing with the second, so tan cube theta is equal to 3 tan theta. We need to find the general solution. Okay, so the thing is, we need to take one in the LHS, otherwise in the RHS, and we can find the solution. So I took each and every term in the LHS, left hand side. So it's nothing but tan cube theta minus 3 tan theta, in which over here the tan theta is common. Yes, tan theta, tan square theta minus 3, and we can find the value as tan theta is equal to 0 and tan square theta minus 3 is equal to 0 one way. So over here tan square theta minus 3, if I take it over here plus 3, yes, tan square theta is equal to 3. So over here it's nothing but root 3 square. According to the general solution, we know the value as tan theta is equal to 0, tan square theta is equal to tan square alpha. We know the value of it. Yes, so we can use that formula and we can find it. So I have just used it over here, tan pi by 3 square. Okay, so tan square theta is equal to tan square alpha. It is in the form of that. So just use the formula and we will be getting the answer. I have just used the formula accordingly. If tan theta is equal to 0, then theta is equal to n pi. Tan square theta is equal to tan square alpha, then the theta is equal to n pi plus or minus alpha. Yes, both the value we need to do it. Okay, at the question itself, it's in the form of tan cube theta. Yes, according to the general solution formula, we know the solution of tan theta is equal to 0, tan square theta is equal to tan square alpha. We know the value of it, but we don't know the value of the tan cube theta. So we have converted it the form of tan square theta. Yes, over here we have converted it and we have found the solution. Sub question, we need to find the general solution of it. So at the RHS, it's of tan theta, so we need to take it as sin theta by cos theta. The cos theta multiply in the LHS, so it will become as sin theta into cos theta equal to sin theta, and take each and every value in the LHS, that is nothing but left hand side, and we can find the general solution very easily. Okay, by using the certain formulas. If any queries, then don't forget to comment. So the third sub question is a quite different, like cos theta plus sin theta is equal to 1. So we need to relate with the general solution formula. So I have just done a quite calculation over here. I have just multiplied each and every term by root 2. It's nothing but root 2, 1 by root 2, it's nothing but cos pi by 4 and sin pi by 4 value. Yes, for that purpose I have divided each term by root 2. Yes, over here 1 by root 2, over here 1 by root 2. So it was in the form of cos theta minus pi by 4 is nothing but cos of a minus b is equal to cos a cos b plus sin a into sin b. In that format I have found it, in which we can find the general solution. Now it is in the form of cos theta is equal to cos alpha. Yes, so we know the general solution is nothing but 2n pi plus or minus alpha. So let's compare with the theta over here is theta minus pi by 4 and alpha is pi by 4. So first we need to take the positive sign, and secondly we need to take the negative sign. So theta minus pi by 4 is equal to 2n pi plus pi by 4. Yes, and just find the value of theta. We have found it. Now take the negative sign of it. Put the negative value and we'll be getting the answer. So the general solution is over here. to the exercise 3.2. okay, it's based on the Cartesian coordinate, polar coordinate, sine rule, cosine rule, projection rule, tan rule, half. Okay, a complete concept, a club of the concept is over here. So over the trigonometry, the basic thing is we need to remember each and every formula. Yes, over here there is a list of the formula is present. We need to remember it for doing the sums. So at the exercise 3.2, the first and second main question, it's based on the Cartesian and polar coordinate. Okay, the Cartesian coordinate is in the form of x comma y. Okay, according to the Cartesian plane. Now the polar coordinate is in the form of r comma theta. Yes, so over here we need to convert from Cartesian to polar, polar to Cartesian, x comma y to r comma theta, and r comma theta into x comma y. Okay, the basic concept is on the first and second main question. Okay, related to the complete concept, a scratch of each and every concept, the Cartesian, polar, conversion, each and everything, I made a separate video. Description box will be getting the link update. So 3.2, the first main question. Okay, the question is given as root 2 comma pi by 4. So the root 2 is nothing but r and theta is equal to pi by 4. It's in the form of polar. Yes, and we need to convert in the Cartesian, that is nothing but x comma y. So we have the formula for converting, it's nothing but x is equal to r cos theta and y is equal to r sin theta. Yes, so just put the value accordingly and we'll be getting the answer. Like r value we know, theta value is given. So x is equal to r cos theta and y is equal to r sin theta. R, okay, theta is nothing but pi by 4 over here. So cos pi by 4 is nothing but 1 by root 2 over here, also 1 by root 2, and we got the answer as y. 1. So the Cartesian coordinate is 1 comma 1. Yes, so let's move to the second main question, first sub question. So each and every sub question is completely correlated. If any queries, then don't forget to comment. Okay, each will be in the form of r comma theta. We need to convert to x comma y. Okay, according to the formula. So over here I took the first main question only. So it is in the form of x and y. We need to convert in the form of r comma theta from Cartesian to polar. So it is in the plus. Yes. So if the x coordinate and y coordinate contains the positive sign, it should lies in the first quadrant. Yes. So the polar coordinate is nothing but r comma theta. So the r value, okay, the formula is nothing but r is equal to root x square plus y square. So r square is equal to x square plus y square, in which r is equal to root x square plus y square, and we got the answer of r. It should be greater than 0, and the theta, it should lies between 0 to 2 pi. Yes. So cos theta is equal to x by r and sin theta is equal to y by r. Just put the value accordingly and we'll be getting the answer of tan theta. It's nothing but tan theta is equal to sin theta by cos theta. Point lies in the first quadrant, the theta lies between 0 to 2 pi, and if tan theta is equal to 1, it's nothing but tan pi by 4. Yes, so the theta is equal to pi by 4 and we got the answer. Okay, a complete concept. If it is lies in the first quadrant, the procedure is absolutely alright. If it lies in the second, third, a quite conversion we need to do it. Okay, make sure to get the link update in the description box. Let's start with the third main question. So in triangle ABC, A angle is given and the B angle is given, and we need to find the ratio of the sides. That is nothing but A ratio to B ratio to C. Okay, in this format we need to find the value. Okay, now we are going to find this with the help of the sine rule method. Okay, that's what we need to do it. So by the sine rule, A by sine A is equal to B by sine B is equal to C by sine C. Yes, in which the ratio things we can find it over here. That is nothing but A by B. It's nothing but sine A by sine B, and B by C. It's nothing but sine B by sine C. Now A ratio to B ratio to C. It's nothing but sine A ratio to sine B ratio to sine C. Now we know that sum of the angle of triangle is nothing but 180 degree. If we have the two angle triangle, the value the other angle we can find it. Yes, it's nothing but A plus B plus C is equal to 180. We can find the value of the C angle. Yes, we need to find the value of A ratio B ratio to C, in which the answer is sine A, sine B, sine C. We need to know the value of it. Okay, we know the value of angle A, angle B, angle C. If we are knowing it, can we put it in the value over here, sine A, sine B over here? Yes, in which we will getting the answer of it. So for A and B, we have the value of as a 45 degree, 60 degree. So sine A, it's nothing but sine 45. Yes, the angle in the given question. So sine 45 is nothing but 1 by root 2. And B angle they have given a 60. So sine B is equal to 60 degree is equal to root 3 by 2. The answer of the question is nothing but sine A, sine B, sine C value. We need to find it. Okay, sine A and sine B we have already found it. Now sine C, and this angle C is nothing but 75 degree, but according to the trigonometry tables we don't know the value of it, so we can find with the help of the compound angles. Nothing but that is nothing but sine of A plus B or sine of A minus B. We need to put the value over here and we'll be getting the answer. That is nothing but sine C is equal to sine 75 degree is nothing but 45 degree plus 30 degree is nothing but sine of A plus B formula we can apply, and we can find the value of sine C if we are found with it. Next, okay, I'll just show it over here. If we have done with then the according to the question we need to find the ratio of sine. That is nothing but A ratio to B ratio to C. So A ratio B ratio to C, as we have done previously, sine A ratio to sine B ratio to sine C. We know the value accordingly. Just put it over here and we'll be getting the answer. Okay. The last thing what I have done it over here. It's nothing but I have done the rationalize the denominator over here, root 2 over here, 2 over here, 2 root 2. So I multiply by root 2 over here and 2 over here at numerator and denominator. If we have done with the calculation, we will be getting the answer over here. Yes. Move to the fourth main question. In triangle ABC, we need to prove it from LHS to RHS or RHS to LHS. Over here, we are going to prove from RHS to LHS. Okay, that we are going to prove it with the help of the sine rule only. Okay, according to the sine rule, we know the formula. It's nothing but A sine A is equal to B sine B is equal to C sine C. Let's represent as the constant. So it will be A. K is a constant. A is equal to K sine A. B is equal to K sine B. Yes. And C is equal to K sine C. Now we are going to put the value in the RHS term. B value we know, C value we know, and the A value we know. Just put the value accordingly. Yes. In which over here the K is common. Yes, take the common and just divide it from numerator and denominator. Yes, we have done with it. Now sine B minus sine C formula, can we use it over here? And sine A. So according to the double angle, sine to theta, it's nothing but 2 sine theta cos theta. If sine theta, then it's nothing but 2 sine theta by 2 and cos theta by 2. Yes, just use the formula accordingly. And over here the cos theta A by 2 and cos A by 2 will be cancelled it off. Yes, and 2 to cancel. Yes, and over here sine of B plus C divided by 2. So we know that A plus B plus C is equal to pi. If B plus C is nothing but pi minus A, just divide by 2 each and every time. If we will do the calculation, we will be getting the answer. Okay, cos pi by 2 minus theta formula, sine A by 2. Yes, in which sine B minus C I have written as like us, and over here sine A by 2, sine A by 2 cancel. That's nothing but the LHS value. Move to the fifth main question. Over here we are going to take the LHS value. Let's prove it to the RHS. Over here we are going to use the cosine rule formula. So let's get started. So let's take the LHS value over here. Yes, we have took it, and over here I have just multiplied with 2 with each and every term, and A and C have kept it over here. It's nothing but A 2 sine square C by 2 and C 2 sine square A. It's absolutely same. Yes, in which over here 1 minus cos theta, it's nothing but 2 sine square theta by 2. Yes, theta over here is C and over here is A. Okay, just the yes. And over here cos C cos A, can we use the cosine rule formula over here? Okay, and just rationalize the denominator with each and every term. Yes, we have done with it. And so A cancel over here, C cancel. Yes, over here the denominator is common, so 2B as a common, and take the other term over here. And over here A square minus A square plus A square, just cancel it off. If we are done with the term, we will be getting the RHS value. Start with the sixth main question. Over here the LHS value is given. We need to prove it to RHS. That's nothing but 0 value. We need to prove it. So we are going to prove it with the help of the sine rule. Yes, the sine rule, we know that A sine A is equal to B sine A is equal to C sine A. We'll just represent as a constant K. Yes, in which A is equal to K sine A, B is equal to K sine B, and C is equal to K sine C. Now we are going to put the value in the LHS value. Okay. We are going to put this term in the LHS value. That is nothing but LHS value is over here. Yes, in which sine B minus C, sine C minus A, sine A minus B, the formula we have. Okay, on the left hand side, I'll just display the formulas. Just go through it. Okay. And we will be getting the answer of sine B minus C, sine C minus A, and sine A minus B. Now, we know that sine B value, okay, sine C value, yes, in which sine B is nothing but B by K. B is equal to K sine B, then sine B is nothing but B by K. Yes, just put the value according to the given content. Yes, the three equation we have gone through it. Now, I'll just take the 1 by K common from each and every term. So it will be 1 by K is common. So multiply with A cube in this equation, B cube over here, C cube over here. Yes. Over here, can we use the formula of the cosine rule? Okay, cos C, cos B, cos A. Okay, the value is over here. So can we use the formula? Yes, we can absolutely use it. And over here, A cube B and 2AB. Okay, according to the formula of cos C. So over here, A and B and cancel. So A square B. So if we will do the calculation, we will be getting the answer as, yes, it will be in this form. And again, if you will multiply with A square, if you will remove the brackets, you will be getting the answer as 0. That's nothing but the RHS value. Move to the seventh main question. Over here in triangle ABC, cot A, cot B, cot C are in AP. It's nothing but the arithmetic progression. Yes. Then show that A square, B square, C square also in the AP. Okay. A and B and C, they have already mentioned it's in the AP. Now we need to prove that A square, B square, C is also on the AP. So it's nothing but we need to prove that A square plus C square is equal to 2B square. If we have done with the proof, then it's absolutely alright. We will be getting the answer. It's R in the AP. Okay, A square plus C square is equal to 2B square. If we have proved it, then it's R in AP. So for that, we are going to use the sine rule formula, and with the given content, we are going to prove it. Yes, so sine A is equal to sine B by B is equal to sine C is equal to K. By the sine rule, we have taken the constant as K. Yes, in which sine A is equal to KA, sine B is equal to KB, and sine C is equal to KC. Now, according to the given question, cot A, cot B, cot C are in AP. If it is in AP, then cot C minus cot B is equal to cot B minus cot A. It's nothing but cot A plus cot C is equal to 2 cot B. Yes, if it's proof, then it's in the AP. Now we need to prove that A square plus C square is equal to 2B square. Yes, so let's get started. Cot A, cot C, cot B. We know the value of cot theta. It's nothing but cos by sine. Yes, okay, according to the angle, I have mentioned it over here. Okay, over here we need to rationalize the denominator. If we have done with it, just use the formula sine A plus C is nothing but sine C cos A plus sine A cos C. Yes, to cot B I have written over here. A plus C is nothing but pi minus B, sine of pi minus B. Sine 180 minus theta, it's nothing but sine theta. And over here, cos B is nothing but cos B by sine B. Yes, and sine B, okay, just do the multiplication, okay, to cos B. Sine B, it's nothing but K into B. Sine square B, it's nothing but K square B square. Sine A, KA, sine C, KC. Yes, in which cos B value, cosine rule also we have done with it. Now this K square, K cancel. Yes, B square by AC and A square plus C square minus B square divided by AC. So this AC cancel and we got the answer. 2B square is equal to A square plus C square. If it is equal, then A square, B square, C square are in AP. Go to the eighth main question. Over here, the question in triangle ABC, A cos A is equal to B cos B. The question itself says it's equal. Then we need to prove that the triangle is either a right angle or an isosceles triangle. Okay, the right angle triangle, it's nothing but if the angle, one of the angle contains a 90 degree. Okay, so total the angle of the triangle will be 3. If one of the angle is 90 degree, then it's called as a right angle. Isosceles triangle is nothing but any two angle if it contains the same. Okay, one angle contains the 60 and the other angle is also 60, then it's equal, then it's called as an isosceles triangle. Yes, let's get started. Now using the sine rule, we just prove it. Okay, so according to the sine rule, a sine a is equal to b sine b is equal to k. So k is nothing but the constant. So it's nothing but a is equal to k sine a, b is equal to k sine b. Now according to the given question, a cos a is equal to b cos b. Now we know the value of a and b. A is equal to k sine a, b is equal to k sine b. Just put the value accordingly. Yes, and multiply 2 at the LHS and RHS in place of k. Okay, it's nothing but 2 sine a cos a sine b, 2 sine b cos b. It's nothing but sine to theta formula. It's nothing but sine to a is equal to sine to b. Yes, in which let's take it in the LHS, sine to a minus sine to b, and we'll just use the formula accordingly. Okay, I'll just list out the formula mentioned at the right hand side so that we'll be getting the clear concept. So over here I have used the a plus b. So a plus b plus c is equal to pi. Yes, a plus b, it's nothing but pi minus c. Yes, so cos of pi minus c, it's nothing but minus cos c. Okay, 2 I have represented over here. So it's nothing but cos c is equal to 0 and sine of a minus b is equal to 0. Yes, cos c is equal to 0. It's nothing but c contains of 90 degree. Yes, 0, it's nothing but cos 90. Yes, so the cos cancels, so c is equal to 90. Over here a minus b is equal to 0. It's nothing but a is equal to b. Yes, the c angle contains 90 degree and the a is equal to b. So the given question, the triangle is either right angle or an isosceles triangle. We have proved it. To the 11th main question, over here in triangle ABC, it's given as we need to prove the second equation. So I'll just make a note, b plus c minus a tan a by 2. Put the formula and we'll be getting the answer accordingly. And secondly, we'll just prove it, get the answer accordingly. Third also we'll be getting the answer, and just combined with it we will be getting the answer same. Yes, I'll just mention it, the first thing, b plus c minus a tan a by 2. Okay, tan a by 2 formula we can use it, a plus b plus c minus 2. It's nothing but b plus c minus a. I have used the a plus b format because it's nothing but 2s. Yes, 2s minus 2a. And over here if we will do the calculation, we'll be getting the answer. It's nothing but the equation 1 I have noted. The same process, do it for the c plus a minus b and a plus b minus c. Okay, according to the given question, if we will see, it's absolutely same. So the question itself asks, we need to prove, we have proved it. Okay, the same procedure, right? If any queries, then don't forget to comment also, and just use the formula accordingly as we have done previously. Just take a note of it. Now let's move to the 12th main question. Over here the LHS value is given, the RHS value. So let's take the LHS and we'll just prove it to the RHS. Sine a by 2 formula, sine b by 2 formula, and sine c by 2 formula. We'll just represent over here. Yes, now take a square root s minus a square, s minus b square, s minus c square, a square, b square, c square. Okay, now the square cancel. Okay, the square root and each and every square cancel it off. Yes, and over here multiply and divide by s. Okay, so that we'll just get the formula of area of triangle ABC. It's nothing but root of s minus a, s minus b, s minus c, and the denominator are absolutely same. That's nothing but the RHS value. Move to the third exercise. This third exercise is completely based on the inverse trigonometric functions. Yes, okay, there is a certain properties, formulas we need to remember for this exercise. Okay, I made a separate video related to the inverse trigonometric function. Each and every concept is available in the description box, not only for inverse, for the previous exercise, the complete concept. Okay, now let's move to the first main question. Over here we need to find the principal value of it. Okay, it's completely correlated with the exercise 3.2. The question is in the form of inverse inverse form, like sine inverse, cos inverse, tan inverse. Yes, it will be in that form. We need to find the value of it. Okay, so I took the first sub question, sine inverse 1 by 2. We need to find the value of it. Okay, range of sine inverse x, it lies between minus pi by 2 pi by 2. So if we have represent sine inverse 1 by 2 is equal to alpha, okay, then the alpha lies between minus pi by 2 pi by 2. It's nothing but the range of sine inverse of x, inverse trigonometric functions of the sine. So it's nothing but sine alpha is equal to 1 by 2. Yes, sine alpha is equal to 1 by 2. 1 by 2, it's nothing but sine of pi by 6, but according to the trigonometry tables, now it is in the form of sine alpha is equal to sine pi by 6. So it's nothing but alpha is equal to pi by 6. Is it lying between minus pi by 2 to plus pi by 2? It's absolutely lying between minus pi by 2 plus pi by 2. So the principal value of the sine inverse of 1 by 2, it's nothing but the pi by 6. Okay, now before moving to the second sub question, we'll just complete with the third sub question and we will move to the second one. Okay, question over here is given as principal value of the tan inverse of x. Okay, it's lying between minus pi by 2 pi. It's an open interval, not the closed. The sign for sine, the interval is closed. Okay, over here is open. So the alpha lies between minus pi by 2 but it's not equal. Yes, so tan inverse of minus 1 is equal to alpha. So it's nothing but tan alpha is equal to minus 1. Yes, minus 1 is nothing but minus of tan pi by 4. Yes, so tan of minus theta, according to the trigonometry function negative angles, it's nothing but minus tan theta. So tan alpha is equal to tan of minus pi by 4. Yes, in which alpha is equal to minus pi by 4. If now this minus of pi by 4 lies between minus pi by 2 plus pi by 2. Yes, is absolutely lying. So the principal solution of the tan inverse of 1, it's nothing but minus pi by 4. We need to find the value of the second. Okay, so cosec inverse of x, we need to find the principal value of it. So the range of cosec inverse of x, it's nothing but minus pi by 2 to pi by 2. Okay, it's in the closed interval minus 0. Okay, excluding 0, it's nothing but the trigonometric functions of the negative angle of inverse cosec. Okay, so we need to find the cosec inverse of 2. So let's represent alpha. So it should be lying between minus pi by 2 to plus pi by 2. Yes, so cosec alpha is equal to 2. Yes, so 2 is nothing but cosec of pi by 6. So alpha is equal to pi by 6, in which is lying between minus pi by 2 to pi. So it's the principal value is pi by 6. Now let's move to the sixth sub question. So the question is given as cos inverse of minus 1 by 2. So the interval of the cos inverse, the range is nothing but 0 to pi. Yes, the angle should lies between 0 to pi. To cos inverse of minus 1 by 2 is equal to alpha. So it's lying between 0 to 2 pi. Yes, cos alpha is equal to minus 1 by 2. 1 by 2 is nothing but cos pi by 3, and minus we have represented over here. Now according to the trigonometric functions of the allied angle, cos of pi minus theta is equal to minus cos theta. So cos of pi minus pi by 3, it's nothing but 2 pi by 3. So alpha is equal to 2 pi by 3 and it's lying between 0 to 2 pi. So the principal value of the cos inverse of minus 1 by 2, it's nothing but 2 pi by 3. First main question, we have found the principal value of it accordingly and we have denoted over here. Now at the second main question, we need to find the principal solution of each and every trigonometric functions and we need to evaluate it. It's nothing but the first sub question, see, tan inverse of 1 plus cos inverse of 1 by 2 plus sine inverse of 1 by 2. We need to specifically mention for each and every trigonometric function, inverse trigonometric function, and we need to sum off. Let's get started. So I took the first thing. Okay, tan inverse of 1. Let's represent alpha and it lies between pi by 2 to minus pi by 2 to plus pi by 2. Yes. And tan alpha is equal to 1. It's nothing but tan pi by 4. So the alpha is equal to pi by 4 and tan inverse of 1 is equal to pi by 4. And it's lying between minus pi by 2 pi. Then the alpha, the principal value we know. So accordingly we need to find the cos inverse of 1 by 2 and sine inverse of 1 by 2 and we need to sum of it. So Let's find the cos inverse of 1 by 2 in which it lies between 0 to pi. The angle, the beta, lies between 0 to pi. So the cos beta is equal to 1 by 2. So 1 by 2 is nothing but cos of pi by 3. So beta is equal to pi by 3. So the pi by 3 is just lying between 0 to pi, so it's nothing but the principal solution. The same format we need to find the value of sine inverse of 1 by 2. Okay, as we have done previously, the answer will be getting as pi by 6, and just sum out with each and every solution and we will be getting the answer as 3 pi by 4. Fourth sub question, we need to find the value of cos inverse of minus root 2 and cot inverse of root 3, and we need to just sum it off as previously we have done for the first sub question. Okay, so one by one, step by step, we'll just discuss it. So cos inverse of minus root 2 is nothing but minus of cos pi by 4. Yes, in which the y, okay, the alpha, okay, over here we need to write it as alpha, in which the alpha should lies between minus pi by 2 to pi. Yes, and so alpha is equal to minus pi by 4. So cos inverse of minus root 3 is nothing but minus pi by 4. Now the cot inverse of root 3, the same procedure. Okay, we need to find it and we need to just sum it off and we will be getting the answer as minus pi by 2. Okay, it's absolutely same as we have done previously. We need to find accordingly each and every inverse of trigonometric function and we need to sum it off, and that's nothing but the answer. Move to the third main question. Okay, over here is absolutely same as we have done previously. The thing is we need to take the LHS value and we need to prove it to the averages, but the procedure as we have done previously is absolutely same. So let's move to the first sub question. So sine inverse of 1 by root 2 minus 3 sine inverse of root 3 by 2. Okay, first find accordingly sine inverse of 1 by root 2 and sine inverse of root 3 by 2 and put it in the value and we'll be getting the answer as minus 3 pi by 4. Yes, sine inverse of 1 by root 2 is equal to alpha. We have put the value in which alpha should lies between minus pi by 2 to pi by 2. It's nothing but the closed interval. Yes, so sine alpha is equal to 1 by root 2, in which 1 by root 2 is nothing but sine of pi by 4. So the alpha is equal to pi by 4, in which lies between minus pi by 2 to pi. Yes, so we have found with it alpha is equal to pi by 4 over here. Now find the value of sine inverse of root 3 by 2. We have represented as beta, so beta should lies between minus pi by 2 to pi by 2. Yes, and find accordingly and we got the answer as pi by 3. Now put it in the LHS value. Yes, the LHS question, according to the question they have written. Now just put the value accordingly, pi by 4 minus of 3 pi by 3. Yes, and do the calculation, and that's nothing but the RHS value. Move to the third sub question. Here the LHS value is given and the RHS value, we have put the value as sine inverse of 3 by 5 is equal to s, cos inverse of 12 by 13 is equal to y, and sine inverse of 56 by 65 is equal to z. Yes, it's based on sine and cos inverse. Yes, so we have represented as x by z for doing the such a calculation in the easiest form. So sine x is nothing but 3 by 5. Yes, in which x lies between 0 to pi by 2. Yes, and sine y is equal to 12 by 13, in which y lies between 0 to pi by 2. Okay, as the question they have given in the inverse, we have converted in the normal form without inverse and we have put the range over here. Yes, and it's nothing but cos x and sine y should be greater than 0. So sine square theta plus cos square theta is equal to 1 according to the trigonometric identities, so that we can find the cos x, the other trigonometric function. The same thing we can find out sine y. The question, we have represented as x, y, z. Yes, so it's nothing but x plus y is equal to z. Yes, so we need to prove that x plus y is equal to z. So we have represented as x plus sine of x plus y is nothing but sine of x cos y plus cos of x sine y. Yes, in which sine of x cos y, we know the value, we have found it. Okay, just put the value accordingly and we will be getting the answer. It's nothing but sine of x plus y. Yes, so sine of x plus y is equal to sine z. If it's equal, then x plus y is equal to z. So that's nothing but the proof. Let's move to the fifth sub question. Over here the LHS value given, we need to prove it to the RHS. Okay, the simplest calculation we will do and we will just find the answer of it. So tan inverse of 1 by 2 plus tan inverse of 1 by 3. Okay, so we have used the formula of tan A plus tan B is nothing but tan A of a plus b divided by 1 minus a into b. Yes, the same accordingly we need to do it, and we will be getting the answer. Just rationalize the denominator, okay, and we can find a tan inverse of 1. So 1 is nothing but tan of pi by 4, so tan cancel, so the answer is pi by 4. That's nothing but the RHS value. To the 6 sub questions. So the question, the LHS value is given. Let's prove it to the RHS. 2 of tan inverse of 1 by 3. So according to the formula, 2 of tan inverse x is nothing but tan inverse of 2x divided by 1 minus x square. Yes, the x is nothing but 1 by 3. Okay, put value accordingly and we will be getting the answer. That's nothing but the RHS value. For the 8th sub question, I took it over here. It's in the form of inverse trigonometric function. We need to take the LHS and let's prove it to the RHS. First thing, find the value of root of 1 minus cos theta divided by 1 plus cos theta. Okay, put the value over here in the LHS value and we'll be getting the answer. So 1 minus cos theta divided by 1 plus cos theta is nothing but 2 sin square theta by 2, and 1 plus cos theta is nothing but 2 cos square theta by 2. Okay, all the required formulas, properties I'll just mention on the either side so that we'll be getting the clear concept of it. Okay, 2 cancel, sin by cos is nothing but tan, so square is over here, so tan square divided by 2. So root of tan square theta divided by 2, it's nothing but 2 and root cancel, so tan of theta by theta, tan of theta by 2. So we have represented as over here. Okay, just put the value accordingly, so tan cancel, theta by 2, so it's nothing but the RHS value. We have came into an end of the video by solving lots of the exercise sums. Even try some more sums like miscellaneous also. We'll make a separate video for the miscellaneous too. Any queries, then don't forget to comment in the comment box, and if this video is so helpful, then do like, share and subscribe.